Hello and welcome to this channel. It's Charles Mbanga, and today we are going to proceed with our topic, data types and operators in Java. So this is the second part of the topic, data types and operators in Java. So today we'll look at arithmetic operators. We'll also look at rational and logical operators. We'll look at assignment operators, shorthand assignments. We'll look at type conversion in assignments. We'll look at compatible types and type conversions in expressions. So if you missed out, you can just check the videos that you have to watch, especially the second video where you get to introduced to how you can run Java on your machine and how you can go about setting the path. So this is a series, okay? So there will be a number of topics that will be looked at, okay? So let's get to these arithmetic operators in Java. So operators in Java, okay, what are they? So we are taught that operators, they are just symbols. These are things that we've been looking at, you know, math symbols that we've been looking at. So in programming, we can as well use these symbols in our expressions, okay? So these symbols just tells the compiler, the Java compiler, we know the Java C, okay? So it tells the compiler to perform specific mathematical operations and manipulations, okay? So this table right here is showing these operators in Java, okay? So the first one is the plus sign, okay? So it is used for addition, okay? And in Java, you can use this expression. You say f plus 7. Maybe, you know, for instance, f is your variable, okay? And 7 is a constant. So you can use this expression, all right? So we have the subtraction, which can be used like this, okay? In Java, we have the asterisk, which is the multiplication sign or operator. So an expression can be of this form in Java. We have the division, okay, which is the forward slash. So an expression can be of this type in Java. We have the modulus, the remainder, okay? So if you want to find the remainder of a number, you use the modulus sign. So in this expression, we are trying to find the remainder of r here. So the remainder of r, okay, looking at s being a value and r having a value. So for example, 10 modulus 3, for example. So we can get the remainder in that way. So this is the increment. Double plus signs is the increment, meaning we are incrementing a value, okay? We are adding a value of 1 to a given value. So this is the decrement, subtracting 1 from a given value, okay? So let's look at these operators, okay? The forward slash, for example. So it is applied to integers, okay? So if we have a remainder that will come out of that division, it will be truncated, meaning it will be destroyed, okay? It won't come out as part of that evaluation. So for example, we say 10 /3 will equal to 3 in integer division. Okay, meaning the remainder will not come out. Okay, so if we want to get the remainder, we use the modulus operator, which gives us the remainder. For example, if we want, like I was saying, we want to get the remainder of 3, we use the modulo sign, which is the percent sign. So we say 10 modulo 3, which is will give us 1. Okay, so we talk about the increment and the decrement operators. So here these operators adds 1 to its operand, and the decrement operator subtracts 1 from the operand. So if we have the operand x and we want to find, for example, x as a value, and you want to add 1 to x, so you say x equals to x plus 1. So for example, x is 10, and then we want to add 1 to x, so we say x equals to x plus 1, which is the same as using the increment operators. So you just say x increment, and then you close by these semicolons. That will give you the next value, which is 11. So the second one, we say x equals to x minus 1. So it's just the same as saying x double subtraction signs, okay, minus signs, which is the decrement. Okay, so you say x decrement, it means you remove a value of 1 from that particular operand. So let's look at this. We are told that the decrement and increment operators can either be a prefix or postfix. Okay, can either prefix or postfix the operand. So what it means by prefix, it means for example, increment operators come before the operand. So this is the prefix form, okay, and this is the postfix form. So if you say you have x and it is equal to 10, or you say you assign 10 to x, and then you want to increment x. So by using the prefix form, you say, okay, and you have, okay, let's say you have you have x, rather you have x, which is assigned the value of 10, and you have y, these are variables, you have y, and you want the value of y to be an increment of the value x. So you say prefix, you prefix increment x, which is 10, as we know here. So the value of y in this case will be 11. Okay, so that's how you can use the prefix, meaning before the increment is done before. Okay, that's the prefix. So let's look at this other form, which is the postfix. So we say we set x to 10, and then we have y, and when we use the postfix form, it means y will be 11. Okay, and then the increment will be done after y. I said 11, y will be 10. Okay, so this means the increment was done before after y was given the value 10. Okay, so y is given 10 and then followed by the increment. So y will be 10, and then x, okay, the x here will be set to 11. Okay, so that is the difference between the the prefix increment and the postfix increment. So we are looking at before assigning the value of x to y, add 1. After assigning the value of x to y, and then add 1. So that is these two increment and decrement operators. These operators will be looked at, and we'll come across these operators in a number of programs. So this is very important to understand from this point, and at this stage you should know and understand these things, because they will keep on coming and they are quite confusing if you really don't know what they mean. Okay, so we don't have an example there, so let us look at relational operators. So what are these? We are told that they look at the relationships, okay, that values have with one another. Okay, so relational operators look at the relationships that values have with one another. So if we say equal to, so when we are equating two values, so if 2 is equal to 2, okay, and if that is true, true come up. Usually these they are of type Boolean. Okay, so we say if 2 is not equal to 3, and then okay, this is the not equal to operator. These are relational operators. So this is the not equal to, this is the equal to. Okay, so this is the greater than, this is the less than, this is the greater than or equal to, this is the less than or equal to. So relational operators are relational and are also logical. So when we look at logical operators, we have they come in a form of true and false. Okay, so values that are of the Boolean type can be connected using logical operators. Okay, so let's look at what this means. So these are logical operators, and the table here is showing us the logical operators. So we have the normal AND. Okay, this is the AND, the operator AND. The meaning is just AND, and we have this it's a pipe. Okay, the meaning is OR. Okay, and we have the caret. The meaning is it's an exclusive OR. Okay, so either one, it should be that one value should be true. Okay, not all of them true, for example, or all of them false. We just need to have one value which is true. Okay, so we also have the double pipe, which is the short circuit OR, and we have the double AND, which is the short circuit AND, and we have the exclamation, okay, which is not, right? So let's look at this truth table right here. So we have been given these two operands, P and Q. So if P is set to false and Q is set to false, if we use this operator AND, okay, so we are evaluating both values or operands. We are evaluating P and Q. So if we say false and false, so P and Q, they are all evaluated to being false. So the result is false. So if we look at P at this time now, it's set to true and Q is false. So if we say Okay, P and Q the same? No, it's not. It's false because they are not the same. One is true and the other is false. Okay, so at this time now we have assigned false to P and then true to Q. P and Q the same? No, it is false. Okay, so they are not the same. At this time we've assigned true to P and true to Q. Are they the same? They are being evaluated. So we find that they are true. They are all true, and it comes out true. So this is how you can use and the logical and in an expression, for example. So if we look at the or here, so if we say P is false and Q is false, so we say P or Q. They are both evaluated to false. If we say P or Q, and then the one that is true will come out. Okay, so P is true. Okay, so if we say false is assigned to P and true is assigned to Q, then we say P or Q. Okay, so the true, which is Q, will be evaluated here. So if we say P or Q and then Q, I mean true, because both of them are true here. Then the caret, which is the exclusive or, so one just has to be evaluated to true. So we are told here we can see that if you say P exclusive or Q, you get to receive false. Okay, and then here you say P is true and Q is false. So here when we are just looking at an exclusive or, so just one value has to be evaluated to true. So we are told that this is true. Okay, and then the same goes to this one because we have Q, which is true, and then we have true right there, and we have these two operands, they are all true, and we have true there. So if we say not P, so okay, not P, so we are just trying to find out if P is true. So not P, so P is not true, it's false, so the value comes out true. Okay, so true is P at this point is true, and then if we say not P, when it is true, it will bring out false. Okay, so if we say not P, if it is false, it's true, because it's not P, it's not true. If we say not P and then it's true, it will bring out false because P is false. So these logical operators, they are of Boolean types, and the result that you get is also of type Boolean. Okay, so we have an example that we can look at. Okay, so let's look at this example. So relational logical operators. So this is the one. Okay, so this example demos relational and logical operators. So we have these two variables of int type, and this one, which is B1 and B2 of Boolean type. So we assign 10 to I, which is int, and we assign 11 to j, which is also int. Okay, so so we use the if statement here. So we say if I is less than j, okay, which is I is 10, and this is true, so this will be printed out. I is less than j, which is true, right? Okay, that's why this will get to be printed out. So we say if I is less than or equal to j, this will be printed out. Okay, I is less than or equal to what? J. So we use the not, the not. Okay, so we say if I is not equal to j, this will be printed out because 10 is not equal to 11, so I is not equal to j. So we say if I is equal to j, this won't execute, okay, because I is not equal to j. So this is equal to, I mean, this is equal to, and then if we say I is equal to j, it won't be printed out. Okay, so if we say I is greater than or equal to j, it won't also execute, okay, because I is not greater than or equal to j. So if we say I is greater than j, this won't also execute. So you see how you can use these operators, okay, relational operators right here. Okay, these are relational operators. Okay, we say relational operators. Okay, and then these are logical operators. Okay, so we have these variables which are of Boolean type. That's why we are setting true and we are setting false. So B1 is true and B2 is false. So if we use the if statement, we say B1 and B2, okay, so this won't execute. Okay, yes, because B1 is true and B2 is false. So when they are both evaluated, you find that they are not the same. So that becomes false. It won't work out like that. So we say if B1 and B2 is not equal to, I mean, is not equal, so this is the not, and this will execute because it's true. So by putting these variables in these brackets, so we are telling the interpreter to put emphasis or give priority to these operands right here in the brackets. Okay, so that's how it works. So that's why even reading, you read like if B1 and B2 is not equal, right? And you say it's true. So we say if B1 and or, this is the or, okay, B2 is true, okay, because one has to come out true here. Okay, so B1 or B2, so the one which is true will come out. So that's the use of you see, the use of this or right here. And then we say if B1 exclusive or B2, and then true come out because one is true as well. Okay, so these are operators, and that's how we can use them. So let's try to run this. Okay, let's try to run this. Okay, so we cd
Command prompt window. CD.
Okay, my bad.
Exiting narrator.
Okay, so we cd onto the desktop and cd onto YouTube, cd onto core, something like that, cd onto data, something like that. So we check out for relation. Okay, this right here. So we clear that up. We say Java C. So let's first try to save this. Control S, so that we don't have issues. Java C relation. Okay. Let's try to compile it. Okay, it's taking some time. Okay, it's compiled. So if we check in the directory, we have the relation logic ops class file there. So we clear that up. We call the interpreter. We say okay. Then we try to clear that up. Okay. So we have these now being our results. So the first one, it's evaluated. The second one, it's evaluated. Third one is evaluated. These did not execute, as we can see. The first one did not execute. Only these three. Okay, you see. So these three, this one, this one did execute. Okay, so that's how we can use relational and logic operators in Java. Okay. That's okay. So let's continue with our slide. So we look at short circuit and the short circuit OR. So these are double end signs and double pipe board. Okay, yeah, it's a pipe. You can call it a pipe, I think. So they are called conditional OR and conditional AND. So this is the conditional OR and this is the conditional AND. So in an AND operation, okay, the conditional AND, which is the short circuit AND. So the first operand, if it is false, the outcome is false, no matter what the value of the second operand is. So what the difference is about between the normal AND, which is just a single AND, and the short circuit AND, which is the double AND, is that the single AND evaluates both operands, while the double AND just evaluates the first one. If it happens that the first operand is true, it will just execute the command like that. So same applies to OR, the short circuit OR. So in an OR operation, if the first operand is true, the outcome of the operation is true no matter what the value of the second operand is. Okay, so difference between the normal and short circuit versions is that the normal operands will always evaluate each operand, but the short circuit versions will evaluate the second operand only when it's necessary. So if it happens that the first operand in the short circuit AND is not true, it can go to evaluating the second operand. Okay, so let's consider an example here. Okay, let's consider an example here. Okay, so let's open a file. Open the file. So it's called short. Okay. So it's called short circuit operations. So this is the example. So we have these three variables of type int, n, d, and q. We have initialized 10, n to 10, and d to 2. So we've initialized these values to n and 2 to d, like that. So we use the if statement. We say if d, okay, is not equal to 0, and using the short circuit AND. So we have this operation right there, and we have the second after the conditional AND, which is the double AND. So we say if d is not equal to 0, which is true, d is not equal to 0, and okay, n modulus d, which is 10, we are trying to find the remainder of 10, the remainder of 10 when we divide by 2. So it is 0, okay, because when we divide 10 by 2, we will get 5. Okay, so we are saying it's equal to 0. So this is also true. This is also true. So we print out to the console d is a factor of n. Okay, so this will just work out at first instance. No need to even look at the second condition, or I mean operation. So d is not equal to 0, and it's true. So it will just print out d is a factor of n. Now we set, we assign 0 to d, okay? And since d is 0, the second operand is not evaluated, okay? So d, since d is 0, the second operand is not evaluated. So we are saying d is not equal to 0, and n modulus d equals to 0. D is a factor of n. So it's also going to work out like that. Now, if we consider also this statement here, we have used the if again. We say if d is not equal to 0 and n modulus d is equal to 0. So here we will have an error which is a divide by 0 error, because what will happen is this operation will be, okay, will be evaluated, as well as the second operation will also be evaluated. Okay, so we'll have a divide by 0 error like that. So let's try to run this. Okay, let's try to run this. We'll say Java C short. Okay, you see we have issues here. We have an error which is saying illegal start of expression here. Okay, so d is not equal to, okay, so we've a space here which should not be there. Okay, so this is a compile time error. So when we go to, there should not be a space there. Okay, so this is the logical not equal operator. So we had a space there which should not be there. So we control S and we head on to our commands. We try to compile again. Okay. So we are told we have this error as well. Okay. We should have a plus there. Okay. Where? Here. Okay. So we should have a plus there. So those are compile time errors. Okay, it's just a normal thing to have those. So this is okay, it has compiled. So Java helps you to get rid of errors before you even go anywhere, okay, with your program. So it's important to, when you're writing a program, you reach a certain level, you compile it so that you try to check out what errors you have. Okay, so let's try to let's try to run. Okay, so it's short. Let's remove the class. So 2 is a factor of 10. So this has executed. Exception in thread main, okay, Java lang.arithmetic exception, divide by 0 at short circuit main, okay, at line 18. So where is line 18? So Java, this is the file, Java short circuits.java at line 18. So that's where this error, arithmetic exception of divide by 0, has occurred. So line 18 is here. So this is the cause of that error. Okay. So if we try to comment that out, we save it. Okay. Try to run it again. Okay, it has compiled. Okay. Try to run it again. So 0 is a factor of 10. Okay. So this one has done what? Has worked out. Okay. So we have these two results right here, because D is 0 and D is not equal to 0, and this. Okay. So the first expression, okay, will be just evaluated. Okay. So that's how you can use short circuit operators. Let's get back to our slides. Okay. Okay. So we look at shorthand assignments. Okay. What are shorthand assignments? We are saying they are called compound operators. Okay. So you can use these assignments to assign values to variables, like taking a shortcut, for example. So we have this example right here, variable x equals to x plus 10. So it can be written as x plus equals to 10. So this is the shorthand form of this. Okay. Similarly, we have x equals to x minus 100. So the shorthand form of that can be this. Okay. That's how, suppose x is a value, like for example 150. Okay, so you can use the shorthand assignments of that nature. So we have this plus equal to, minus equal to, asterisk, which is multiplication, equal to. We have divide equal to, modulus equal to, and, which is the logical, the operator, okay, equal to, and this logical or equal to, and exclusive or equal to. So you can use these values, I mean rather these operators in this way. Okay, so there's an example here. Let's try to look at it. Okay, let's try to look at it, try to look at it. Side effects. Okay, side effects. Okay, so what are we saying here? Okay, so here I is still implemented even though if statement fails. Okay, so we have okay, do we have to look at this example? Not really, we don't have. Okay, so okay, this is just, we can call it an addition of the increment. This is the prefix increment, so we can look at it. So we have the variable I, and of type int, we have assigned 0 to I, and we say if false, and we increment I. So this is the prefix increment. So before anything is done, I will be incremented, even if the statement fails. So we have if I incremented, even if it, because I is 0, even if I is 1, we say is less than 1, and then we say this is the statement. If statement is executed, that's 1. So this is what will be displayed. Okay, so this is what will be displayed. I will be 1. Okay, and here in this case I is not incremented because the short circuit operator skips the increment. Okay, so if I is false, okay, and we are just looking at this, okay, the first operation or the first condition. So this will be not considered if false and I is incremented. So this still won't be executed. Okay, but what will be executed is the value. Okay, the one will be displayed. So let's, for us to understand, let's try to look at the execution of the code, I mean our program. So we clear that up. So we try to compile it. So we have these errors. Okay, so we don't have a semicolon there. Also don't have a semicolon there. Save it. Yeah, try to compile it again. Okay, we try to run it again. No. Okay, so you cannot run with here. So run it again. So if statement executed, so the value of I is 1. If statement executed, the value of I is still 1. Okay, all right, because on top here where I was incremented to to 1. Okay, so even the second execution, I will come with the value 1, even if this was not executed, but because this is what has been executed. Okay, so we are saying I comes with the value of 1 even here, because here it was incremented, here it was 0, here it's incremented, it gets the value 1, even here it will get the value 1. So this is how you can use the post increment and the prefix increment. So let us look at type conversions. Okay, so when compatible types are mixed in an assignment, the value of the right side is automatically converted to the type of the left side. So type conversions, we are looking at types such as int, okay, and byte, maybe trying to convert an int to a byte, okay, a float to a double. We can actually achieve that with Java. Okay, so when one type of data is assigned to another type of variable, an automatic conversion will take place if the two types are compatible. So you cannot try to, for example, convert a variable of type string to double, for example, because these are not compatible. Okay, so you need to have variables that are compatible. So what are we saying? So we are saying that the destination type is larger than the source type. So these are the conditions. So you achieve automatic conversion if the two types are compatible. 1, 2, the destination type is larger than the source type. So a widening conversion takes place. Okay, we'll understand this by looking at an example. So automatic conversion from byte to int can be applied in that case. Okay, because the destination type, we are saying from byte to int, because the destination int is larger than what? The source type, which is the byte type. Okay, so if we look at this example, okay, if we look at this example, we say long float, is it long double, long to double. So we are trying to convert long to double. So we have long L, okay, we have double D, and then a long should have capital L. This value, we are saying that it's a long value. Okay, so we can automatically convert this long to a double, okay, by just automatically assigning L to D like that. So we have system, we have to print out that. So we say L and D. Okay, so we'll look at this. Okay, so let's try to compile it. Let's try to compile it. Okay, so let's clear that up. So we say Java C long, okay, and we hit enter. Okay, so we say Java long, we remove the class, we hit enter. So we have long is this value and double is this value. Okay, we have this decimal point. So a double, a float, they are values with decimal points. Okay, so this is an automatic conversion whereby we have a long, and this is the source type of long. The source is long, and the destination is double. So an automatic conversion will only take place if the destination is bigger than the source. So look at the type that you would want to convert. Understand that the source, which is the one that you want to convert to the other type, should be smaller than the destination. So that's just the logic that we need to understand. Let us continue and look at the slide. Okay. So we have looked at this example, long to double. Let us also look at this statement right here. We are told that the int type is always large enough to hold or valid byte values. Okay, so the int is enough, it's big to hold valid byte values. So casting and incompatible types. So we can cast incompatible types. We were looking at converting compatible types. For example, a double and a long, they are compatible. Okay, that is an automatic conversion that takes place. Now, when we want to convert incompatible types, we look at casting. That is casting that is used. So the concept of casting, what is it? So we are saying a cast is an instruction to the compiler to convert one type into another. So it requests an explicit type conversion. You have to explicitly, okay, tell the compiler to say, do this. Okay. When a cast involves a narrowing conversion, information might be lost. A narrowing conversion can be where you are converting a big type into a small type. So some information will be truncated like that. To be truncated, it will be cut. Okay, so that will lead to information loss. So when a floating point value is cast into an integer, for example, the component of the fraction or the fractional component will be lost due to truncation. Okay, that is the narrowing conversion. So we have this example. We are told that if float 2.44, if we convert it to an int, we just have 2. This will be lost. We have the float 0.44 will be lost. We just have 0. Okay. So I'm saying the 0.44 will be lost. So we just have 2. So let us consider a cast demo. Okay. Cast demo. Let's look at this example right here. Use cast. Now we say cast demo. Cast demo. So this example here demonstrates a casting when we are trying to convert incompatible types. So what are we saying? We have these two variables which are of double type. We have a byte, we have an int, we have also a character which is char, which is ch. So we have these variables right here. So we assign 10.0 to x, we assign 3.0 to y. So if we try to cast, okay, these doubles to int, so this is the form of a cast. Okay, so we say it's in this form. Okay, we have typecast, and then the expression here, expression. So casting takes this form right here. the typecast and the expression. So this is the typecast, okay, which is int in these brackets, and the expression also here. So this is the expression, which is an integer division. Okay, so we are dividing these doubles right there, and we want to cast double to int. So casting will take place when you do that. Okay, so what are we saying here? We are saying I, which is an int, okay, will be assigned the value of this cast. Okay, so if we divide 3 into 10, we'll have something like 3, right? And then, okay, since this is an int, we are saying, I think the 0 will also go. Truncation will occur. Okay, so that will be our answer. Next, we assign 100 to I, and we want to convert B. Okay, so we say I to B. I, which is an int, and we want an int to take the form of byte. No loss of information here. A byte can hold 100. Okay, so I is an int here. We know that I is an int, which is here, int I. So here we're saying I, we just assign it 100, because here it was assigned this value, and we need to reassign again here so that this is forgotten. So it will be printed. The value of B is 100. So next we assign 257 to I, and then we say we also want to cast I to B, which is byte, and information will be lost. 257 is too large for a byte. It will be printed. We'll see. And then we have the byte, which is 88. This is the ask code for X. So if we try to cast B to a character, okay, so that we get to see the character X. So this is how we can cast. So we will get the character X. So we say Control S. Okay, I'm using a free version of Sublime Text. So let's hit this, and we say compile. We say cast. Okay. So we say Java cast. We remove the dot class, the extension class. So we have the integer outcome of X is 3, because we are casting doubles, so there will be truncation. The zeros will go. So that's why the zeros here, they have gone, because double is bigger than what? Than float. I mean, than rather, sorry, int. Okay, so there is been truncation. Okay, so the value of B is 100. It's 100 because a byte can hold 100. The value of B is, okay, information will be lost. It's just 1 here. Instead of printing out 257, it prints out 1. Okay, and then the value of CH is X. 88 is as a character, okay, is X. Okay. So that's how you can use cast, or cast to cast incompatible type. So incompatible types cannot be converted, but they can be they can be cast. Okay, so let's look at operator precedency. What should come first and what should come last. So we are saying that this table right here, it shows the precedence, the order of precedence for Java operators from highest to lowest. And we have the operator, which is the postfix. The postfix, if it is found in your expression or your statement or your line of code, if there is a postfix, it will be the first to be considered. Or if there is a post fix decrement, the postfix increment or the postfix decrement, these will be the top, will be the first to be considered. Okay, if there will be a prefix, okay, increment and the prefix decrement, they will come second. The note will also come second. The unary addition will also come second. The unary subtraction will come second. And if there is typecast, if you have some casting in your statement, they will come second. And then multiplication will follow. If there's anything, there are operations to do with multiplication and division and modulus. These are at the same level, the third level. And then the fourth is plus and minus. And then the fifth is greater than or equal to, less than or equal to. These are at the same level. And then equal to comes at the 60th level, and not equal to, okay? And then the exclusive or, and then the conditional and, okay? Like that. And then we have the conditional or, and then we have the assignment, and then we have operation assignment. So that's these are the lowest operators, okay? So from highest to the lowest, okay? So let's look at an example, which is the logical operation table, okay? So let's look at that. Okay. So logical operation table, which is right there. So we have this class logical op table. So we have two variables, P and Q. Okay, and we have this right here. Okay, we have can we look at this example right now? No. Okay, so no. So let's look at something else. Let's just proceed with our slide. Okay, so type conversions in expressions. Okay, what are they? So we are told that different types of data can be mixed within expressions. They are all converted to the same type. Okay, that is called type promotion. So type conversions in expressions. So you can convert types, you can mix types within an expression so that they become same, and it is called type promotion. So for example, a character, a byte, and a short values can be promoted to int. So these are compatible types. So if we are looking at, for example, direct conversion or even casting, we saw that a byte can be cast to a character, okay, and a byte can be cast to an int, like that. So these, a character, a byte, and a short can be promoted to an int. So if one operand is a long, the whole expression is promoted to a long. That is the type conversion of expressions. So if we have an operand which is a float, the entire expression is promoted to a float. Okay. So if we have an operand which is a double, the entire expression is promoted to a double. So what are we saying? Promotions apply only to the values operated upon when an expression is evaluated. So let us look at an example of type conversion. Okay. So let us look at promo demo. Okay, so we have this example right here. So we have these variables, b of byte type, we have I of int type, and we have assigned 10 to b, and we want to convert b. Okay, we assign the value of b multiplied by b to I. Here, no cast is needed because these are of the same type, and the destination is larger than the source. Here we say b equals to 10, and then we want to assign b to what? To b. Here we need a cast, okay, because these a byte cannot be, we are taking a byte back to what? To an int. Okay, so we need what? A cast like that. So if we say system dot out dot print ln, and then we say b plus, okay, value, we say value of b plus b, yeah, we call it, and here we say, okay, system, we output it dot println, okay, then we say I, just output I like that. Okay, so we say control, and then we try to compile it. We close that, we say Java C, comma. So we try to compile. It's compiled, we try to run it. Remove the dot class. So we have 100 and we have 100. Okay, so this is the promotion of types. Okay, so this is just go through the examples, try them on your own. You get you pay attention, you get to understand what this actually means. So you cannot get some of these concepts at first attempt. Okay, so just go through them, take your time. That's when everything now will come, you make sense of stuff. All right, so time is you need to put in time and effort just to understand certain concepts. They don't just come right there and then. Okay, so we say if the value of a byte variable is promoted to int inside an expression, outside the expression the variable is still a byte. Okay, if the value of a byte, for example, which is a variable, is promoted to an int inside an expression, so outside the expression the variable is still a byte. Let's look at this example, the use cast, maybe, okay, so that we get to know that. Okay, so we say, yeah, use casts. So we have the variable I, of int type. We use the for loop. We are looping. Okay. So if we are saying for I is initialized to 0 and I is less than 5, I increment. Okay. So the first loop, I will be 0. Second loop, I will be incremented to 1. You see how the post fix increment is being used. So in this loop, it loops like, okay, for 5 times. So we are saying we want to print I here at the first loop. I will be 0, and then I divided by 3 will have, okay, will be given the result. Okay, so next I will be 1, and then we'll have I divided by 3 with fractions like that, because we have done a cast here. Okay, because okay, you see that you understand that casting can also be done in your the print method. Okay, so we are casting everything of the result of this expression right here to a double. Okay, so here we are just printing a new line, nothing special. So let's try to run this. We see. So we say Java C use. Okay. And then okay, it has compiled. We say use. Remove the extension. And then okay. So it has looped how many times? 1, 2, 3, 4, 5. So by initializing I to 0 and we say I is less than 5, so it will go 5 times, and we increment I. So the first loop, I is 0, divided by 3 is 0. The second, okay, and then it goes to this statement, I divided by 3 with fractions, so we get 0.0. And then the second loop, I is incremented to 1, okay, and then I, which is 1 divided by 3 is 0 with fractions, 0 dot that. Second I becomes 2 until we come to this. So that is how you can use casts even in your printer and in your print method. Okay, and you can also cast like that. Okay, and so here we've demonstrated, we've now understood why these increments and decrements are so important. Okay, so let us look at an example. I mean, rather, we look at the slide. Okay, so I think we are winding up. So let's look at spacing and parentheses. Okay, so tabs. So on your keyboard, you see the tab there. So tabs and spaces in programming make it more readable. So you can tab up, you can add spaces to your expressions. Okay, just to make your expressions readable. So for example, the first one, no space, no. Okay, it will be hard for someone to review this code right here, but if there is space like that, looks nice and it becomes readable. Also this one, say no, and this one looks good. Okay, you can read this statement right here. So that is about spacing and parentheses, just something that you should know as a programmer. Okay, we've come to the end of the video, and I'm so happy that we're making this progress. Okay, so good things don't come easily. We just need to put in our best, we put in our time, and with time, all these things will start to make sense, and the sky will be the limit. So keep on going high and high. Okay, so subscribe to the channel, like the video so that we can have the algorithm take the video even to other people who would like to learn about this stuff. It's me, Charles Mvanga, at Thriving Code. I'm so delighted to be doing this stuff, and just watch out for the next videos. Thank you.